Oh, it's working now. Weird. So, so the principles of the performance efficiency pillar, right? So what is the performance efficiency? Is the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. So you have to select, review, monitor, and trade-offs. Okay, so we select the right resources types for computing, storage, and databases and networking. So you have to make a selection of the services that you're going to use based on their category. Like I said before, computing, storage, databases, and networking. Those are four of the main components of every architecture. Right? You have to review your selection using benchmarking and load tests. Like I said before, you have to test your system, right? And review the selection that you made. That's very important because we may select services that we don't really need, and that's a big mistake, right? Also, you can use monitoring to know when your performance degrades, and for that we have the guy. We know the guy already, and is CloudWatch, right? And also, you can take action based on that alarm, you know, so it doesn't impact the customer's experience, which is very important when you have a business. Very important. And then you have to make architectural trade-offs, like, one moment. And with these trade-offs, what you do is just maximize the performance and efficiency of this system, right? Maybe you want to use a cache to improve the performance and reduce the load of your database, right? So caching, remember, ElastiCache for your RDS, all right? So the design principles, the first thing that you have to do is democratize advanced technologies. So what it means is that, technologies that are difficult to implement, they can become easier to consume by pushing the knowledge and complexity in the cloud's vendors domain. You know, so rather than having your IT team learn how to host and run a new technology, they can consume it as a device, as a service. For example, NoSQL databases, video transcoding, and machine learning. Those are technologies that require expertise that is not evenly dispersed across the technical community. So you have to think about that. So in the case of the cloud, these technologies that I just spoke about, they become services that your team can consume while focusing on product development rather than resource provisioning and management, right? So when you do that, the next what you have to do is just go global in minutes. That's one of the uh, 6 benefits of the cloud, right? That you can go global in minutes. When it says in minutes, it's because, for example, when you create a cloud formation template, it takes some minutes for the entire template to be run and the resources to be created. And but you can be global in minutes, which is, like I said before, is one of the benefits of AWS. Use serverless architectures. Why would you use that? Do you have an idea, guys? Why would I use a serverless architecture instead of a server-based architecture?
Less to maintain.
Right?
Because we can execute just a code.
I'm sorry?
Like Lambda. We can execute the code, so like Lambda, for example.
Lambda?
Yes.
Okay.
Spend
Yes,
more time working on code and less time working on your infrastructure.
that is correct. You can work more for the business, and dedicate more time to the business than, working on servers, right? And when you have servers, you have to be thinking about, running and maintaining the services to process traditional compute activities. And for example, you may have some storage services like S3, and this event services can host the code for you, okay, like S3, which is part of the serverless architecture, right? So you don't have to worry about the operational burden of managing servers, and you can lower transactional costs because the serverless architectures, that's managed and operated by AWS. So it can be scaled at large, serverless. When you use Lambda, Lambda is highly available by nature, and so is DynamoDB. It has auto scaling as well. And S3, when you create an S3 bucket, it automatically provisions copies of those files in 3 availability zones. So serverless is very popular nowadays. It's trending a lot. People are going serverless to focus more on other things that are important, maybe more important than running and maintaining servers, right? So you have to experiment more often. So when you have virtual and automated services and resources, you can have some competitive testing using different types of instances, storage, and configuration. So experimenting is the way that you can learn more, and you can have, a better architecture, right? How do you learn AWS? By experimenting with the console and the CLI and CloudFormation, right? So that's very important too, right? Now, achieve mechanical sympathy. What it means is that you can use the technology approach that aligns the best to what you're trying to achieve, right? Let's say that if you're accustomed to using SQL, for example, you might experiment and discover NoSQL, and probably you decide that NoSQL is more efficient for you. And when I say NoSQL, is DynamoDB, right? You can also consider data access patterns when selecting database and storage approaches. So these are things that, like I have said so many times, you have to architect before you do anything, right? Some of the things that you guys struggled with when you were working on the project, I was observing you guys, it's that you created something and then you have to recreate it again because you missed something important. That happens when there's a lack of design. If you design everything from the beginning, and you don't have to design the entire thing, because throughout the course of the software or the architecture that you're working on, there must be, or there will be, other changes that you have to tweak your infrastructure, but you have to leave room for that when you create. You cannot just create things, and like we spoke about before, when you create the VPC and the subnetting, you have to leave room for more IP addresses just in case your architecture changes over time. So that's very important. So the key services for performance efficiency are the followings. You have the areas here: selection, compute, storage, database, and network, like we mentioned before. So here we have the AWS, which you already know: auto scaling, Amazon S3, RDS, DynamoDB, Amazon VPC, Amazon Route 53, AWS Direct Connect. So all these services already, right? So in the review, so what do we do in the review? What are we trying to review? We're trying to check that these services are what we need, right? And then you're going to check the blocks and what is new in AWS. Why? Because sometimes they have all the services that perform the same or similar, and you can save money, all right? And also, the blocks from AWS that sometimes they shed light on important pieces of information that you may need throughout the development process or the architecting process. Right? Monitoring, we have this guy here, Amazon CloudWatch and Lambda. Lambda doesn't monitor anything. Lambda is an event trigger serverless service that works in conjunction with Amazon CloudWatch. Okay, they put it here as part of the monitoring system, but you don't use Lambda to monitor it, right? It's just part of the monitoring system. I don't know if you understand what I'm saying. When I say that you don't use it for monitor, it's just that Lambda by itself doesn't monitor anything, right? It can help monitoring when it works with Amazon CloudWatch. Right? Trade-offs, we have these guys here, Amazon CloudFront, Amazon ElastiCache, AWS Snowball, and RDS as well. So the improvements of the infrastructure efficiency. We have here to have the optimal EC2 instance size. You can evaluate the most important performance metrics for your application and choose the appropriate instance family and instance type. That's super important, right? You should have like a design document. You know, it could be in PDF or it could be in Excel or anything, just to have like, you know, like a table of all the things that you have to create. And then you can start thinking about the family and the instance type. What are we going to choose for this particular EC2 instance? It's bad practice to create it just when you start architecting. That's not good. It should be designed before you start, right? Avoid over provisioning and under provisioning. You know, this is very important because when you have EC2 instances on premises, right? Well, actually not EC2 instances. If you have EC2 instances on premises, it means that you are in the cloud. Hybrid, but you are in the cloud. So if you have servers in your office, right, you may be over provisioned because, you know, there may be some services that you don't need, some servers that are gonna be there for nothing. You're not gonna use them. Or you can go to the other extreme when you have servers that are enough, so you need more, right? So you can change the instance types and sizes as your needs change. Once the sky is created, you can change the instance type, right? And the size as well. Right? You can analyze if your application can scale across multiple EC2 instances. Design your application that are resilient to reboot and relaunch to allow for scaling horizontally instead of vertically where possible. Yes, you know, it's better to create another EC2 instance than you know, increasing the capacity of the EC2 instance. That might be more expensive than creating an identical EC2 instance and then have two instead of one. That might be more expensive than having one that is like 2 or 3, 4 steps up in the capacity level. That's not recommended at all. Okay, it says here when possible, so you can try to avoid that as much as possible. So guys, it's right now it's 2:47. Let's have a 10 minutes break, and then we're going to be back at 2:57.
Okay.
Perfect. See you soon.
Hey guys, we're back.
Yeah, I'm here.
I'm here.
Yeah. So here we have a comparison of the different storage services that AWS has. Of course, we're still missing here Amazon Glacier Deep, and there's another one. So you can see here the average latency for these 4 services. Hey guys, we're back. Yeah.
I'm here.
I'm here.
Yeah. So here we have a comparison of the different. So we have here a latency that the instance store, also known as ephemeral, right? Ephemeral storage is the one that, you know, when you create an EC2 instance, if you delete the EC2 instance, it will disappear, right? It's like RAM memory, right? When you close your computer, everything that is in your RAM memory just disappears, right? So we also have EBS, which is in milliseconds, right? That's the time that it takes for customers to have the information that they're requesting, right? And then you have Amazon S3, which is milliseconds, seconds, minutes, depending on the size of the file, right? And then we have these guys, you know, that can take minutes and hours. Remember that it has 3 different ways of delivering the messages. It has expedited, standard, and bulk. Remember that expedited takes from 1 to 5 minutes, right? And then standard takes from 3 to 5 hours. And then Glacier takes from 5 to 12 hours. So it depends on where you store your files. So the data volume in an instance store can go from 4 gigabytes to 48 terabytes, right? In the case of Amazon EBS, it goes from 1 gigabyte to 16 gigabyte. So it's a little more than 1 gigabyte, right? It's a little more. And Amazon S3, there's no limit for this, and there's no limit for Amazon Glacier. You know that Amazon S3 is virtually unlimited, right? And so is Glacier, because Glacier it's just a storage class of S3. The item size that you can have, this is block storage. You know that this is a block storage, and these guys are object storage. It's something that you saw in your for your cloud practitioner exam, right? So the maximum is 5 terabytes. It's the maximum per object in Amazon S3, and it's 40 terabytes maximum for each object in Glacier, right? The request rate is very high here, very high for this guy, low to high, and with no limits in Amazon S3, and very low and no limits. So this gets a lot of requests, and so does this one. This one can be low or very high, and this one is very low because, you know, this is archiving, right? So when you put in Amazon Glacier, it's because people are not accessing it frequently like it did before. Now the cost for instance store is this 2 instance cost, right? We see that EBS is more expensive than Amazon S3 and Glacier, okay? Because it's very convenient to have an EBS volume. Remember that if you change just a portion of the file, you don't have to update the entire file. It's just updating you don't have to do it. It's just when you do it, it only updates the block where the information is. That's why it's a block store. It's an elastic block store. In the case of Amazon S3, it's cheaper because you have to work more than EBS. If you change a portion of the file with Amazon S3 will update the entire file, not the block only, right? And this is the same because it's just, like I said before, it's just a storage class of S3. The durability of this guy is low because as soon as you know, if you just delete the EC2 instance, this will be deleted too. So it's very low. This one is high, right? Because why? Because you can still preserve that volume, right? You can still preserve that volume when you delete the EC2 instance. You can preserve that, right? Of course, you have to do some configuration to preserve it, right? Otherwise, it will be deleted well, or it will be in use but not attached to an EC2 instance. And Glacier, Amazon S3 is very high. You know, it has a 11 nines durability, and so does Amazon Glacier, right? That's very durable, very. And it goes from the hottest to the coldest, because you know when it's hot, it gets a lot of requests, right? And as you progress to the right here, it becomes colder and colder, colder, because people, you know, are accessing the files less and less as you go through the right, to the right.
Yeah, this is a very interesting chart. And I say that because if you're, not this one, the previous one, this one. So if the maximum size of an S3 is 5 terabytes, right?
Yes.
And then Amazon Glacier is 40 terabytes. If you need to extract something that has 40 terabytes size, where would you put it? If Amazon S3 will not support it.
Okay. This is per object.
Yeah, for objects, right?
Per
Isn't that what this is about?
If use is bigger than 40 terabytes, is it what you mean? If it is bigger than 5?
So S3 maximum is 5 terabytes, right? Of an item, just one item, one object.
That's right.
And then Amazon Glacier, you can go up to 40 terabytes per item, per object.
Yes.
So if you need to extract something that it's, let's say, 39 terabytes, where would you put it? Because Amazon S3 will not support it, which is the object repository for faster access. What will be the location where you can put an object that it's of that size in Amazon Web Services? And yeah, and good question on that. Where you load it from?
So I don't get your question. I still don't get your question. These are
the maximum size of Glacier. It's 40 terabytes, right?
That is right.
And I have an object that is 39. Where can I extract that document, that object to? Where can I put it?
Okay, you can put an S3, but you have to use something called multi-part load. Okay.
So it's parsing the document.
Multi-part unload.
Ah, see, this is something that I don't remember saying. Interesting. So what is this? Like a pointer system? Is it pointing to?
No, it's just like that. You know, dividing. It's like partitions the file, right? And then you can upload it if it is 7 terabytes, for example. You can upload the files in multi-part, like a partition, but you still can put it there. Okay. So when you send the request to
initiate this link, please.
Yeah, I will. So when you multi-part loading is a 3-step process. You initiate the upload, you upload the object parts, and after you have uploaded all the parts, you complete the multi-part upload. Upon receiving the complete multi-part upload request, Amazon S3 construct the object from the uploaded parts, and you can then access the object just as you would any other object in your bucket.
Where? Okay, I'll read this. That's interesting.
So I'm gonna put it in the chat.
Yeah.
So database components, we have here DynamoDB. You know, DynamoDB has a latency of under a single digit. You know, it's very fast. Amazon RDS is in milliseconds a second. Amazon S3, Amazon Redshift is seconds and milliseconds, right? So the data volume, there's no limit for DynamoDB. Amazon RDS has a limit between 5 gigabytes and 64 terabytes maximum. It depends on the engine. And Redshift has 1.6 terabyte maximum. This makes sense because Redshift it's a data house, a data warehouse. So it has a lot of space for data. Item size in kilobytes is maximum is 400 kilobytes maximum. That's the maximum for per item, right? The kilobyte for Amazon RDS, it depends on the row size, right? And the 64K maximum for Amazon Redshift. See, it's very interesting that DynamoDB, which is a single database table, a single table database, I'm sorry, has more capacity for one item than Amazon Redshift, that is a warehouse. But this is per item, right? The request rate for DynamoDB is very high. It's high for Amazon RDS and it's low for Amazon Redshift. As you can see, Redshift is the cheapest one of the three options. Amazon DynamoDB is it's expensive. I mean, it's costly, and so is Amazon RDS, depending on whatever you are storing, right? The durability is very high for DynamoDB, high for RDSs, and high for Amazon Redshift. Usually people don't save assets or store assets in DynamoDB. You store the metadata, like the name of the picture, the size of the picture, things like that. The picture will save it in S3, right? So metadata, you upload it or you store it in DynamoDB, and the asset or the file you store in S3. ElastiCache is a web service that simplifies deploying, operating, and scaling in memory cache in the cloud. ElastiCache. So whenever you see in memory cache, that's ElastiCache, right? It improves performance, of course, when you put this in front of an RDS, it caches the information that is, I've repeated this like 1,000 times. What it does is, you know, when the customer requests information from database, ElastiCache will cache this information, and then next time the customer will have to travel the entire way to the RDS instance. Instead, it gets the information from the ElastiCache. Okay. It simplifies and offloads the management, monitoring, operation of the in-memory cache environment. It's what I said before. And supports Memcache and Redis, open source and caching engine. So when you read about ElastiCache, you can read about the two flavors that it has. It's right here. Redis and Memcache. Okay. So whenever you hear about, you know, heavy, heavy, that's Redis. Okay. So Redis and Memcache are popular open source in-memory data data stores. Although they are both easy to use and offer high performance, there are important differences to consider when choosing an engine. Memcached is designed for simplicity, while Redis offers a rich set of features that make it effective for a wide range of use cases. Understand your requirements and what each engine offers to decide which solution better meets your needs. As you can see here, there's a bunch of things that Memcache doesn't have, right? Already has this. So this is something that you can research on your own later. I'm gonna put the link here. So Amazon Kinesis Streams, this is a service that is used for big data. If you're taking your exam in big data, you're gonna see these guys, you know, all the ins and outs of this guy. It's super crazy in that exam because it has to do with big data and streaming information. So what it does is it enables you to build custom applications that process and analyze streaming data. And something that is very important about Amazon Kinesis is that it's real-time data processing. Okay, that's very important. You can continuously capture and store terabytes of data per hour from hundreds of thousands of sources, such as website clean streams, financial transactions, social media feeds, IT logs. All right. So the KCL, which is the Kinesis client library, is used for building applications, stream data, and power real-time dashboards, generate alerts, and so forth. So Amazon Kinesis is presented in three different ways. Amazon Kinesis streams, Amazon Kinesis data analytics, and Amazon Kinesis Firehose. Okay, those are the three ways that Amazon Kinesis is presented. Data streams, data analytics, and data firehose. Okay. So what do we do with data streams, which is the one that we're talking about? It's just a scalable and durable real-time. That's very important. Data stream service that can continuously capture gigabytes of data per second for hundreds of sources. This is very important because this is the one that grabs the information from the streams and puts it in S3, right? In S3 and Splunk. See here, S3, those are the destination sources of Amazon Kinesis Firehose. Amazon S3, Amazon Redshift, Amazon Elasticsearch, and Splunk, which is a third-party service, okay? So whenever you work with Amazon Streams, you can use this guy just to put the information in these destinations. And also analytics is just processing the data in real time, right? So is the easiest way to process data streams in real time with SQL or Java without having to learn new programming languages or processing frameworks. All right. Exercise, improve this architecture. In this exercise, your small business owner, your website frequently experiences intermittent page load issues, and users often report significant load times. To help resolve this issue, you will do two things. Review the architecture and ask questions to identify where improvements can be made to increase the system's performance efficiency. And consider performance efficiency enhancements in accordance with the well-architected performance efficiency pillar. Okay, so here, guys, you're gonna review this architecture and just check where improvements can be made, right? So take a look at this graph and let me know what improvements you can make here. No suggestions?
Sorry. You can, for some odd reason, it's in one availability zone, so you can make it multi-AZ. Have a load balancer between them if you want. Also for redundancy and availability. You can add an auto scaling group, just in case you need it, actually, because it seems like you have two app servers on the private subnet.
Yeah.
Is the public subnet highly available?
No.
Why not?
T2 micro.
It's in the single zone.
The instance type doesn't matter.
Yeah.
Instance type is for performance.
No, but that's what I'm saying. Like you said, it like, is it highly available? Well, like if it was bombarded, right? If this is on the web server side, right, and it's just allowing connecting traffic, right, and you were to DDoS it, I don't think a T2 micro could handle it. So that's why I was saying you could do dual AZ, like just have two availability zones and then filter it and have a load balancing and all scaling just in case, shit hits the fan.
Is this a regular EC2 instance? The
No,
one in the public subnet? What is it?
it's a NAT.
It's a NAT instance. What happens if it goes down?
You can't connect to the web server.
To the
Are you
private.
sure?
To the private.
Sorry, the private.
That is right. So what can we create to make it more highly available?
You need two availability zones, two public subnets, two private subnets, 3 replicas for your RDS, and I will put elastic load balancers to balance the load.
Okay. And what do we do with the NAT instance?
And the NAT instance, we need to do something, but I'm not sure what.
Change it
We
to
just
the NAT
said-
gateway.
We only have, oh, sorry, go ahead. No, go.
Switch it to a NAT gateway.
That is correct. So what we have to do is eliminate the NAT instance and create a NAT gateway.
And NAT gateway. Oh, that's right. Yeah. You're
NAT
right.
gateway is more highly available than NAT instance. Right. So this is a solution that they give here.
So what is the answer?
This one. The NAT gateway is basically managed for us, and the NAT we have to manage, right?
Uh-huh.
That is correct. So here we were missing ElastiCache. See there?
Ah, yes, the ElastiCache in front of the RDS.
Right. And we may need some database here, session info, and Amazon S3. So for that, you will create an endpoint, AWS endpoint for these guys, because like we said before, these guys don't need to be in a VPC, right? You can connect direct to them from the
VPC.
internet without
Oh.
using a VPC. We are put it inside the VPC.
So would you do an endpoint? Would you do an endpoint from the VPC to DynamoDB and Amazon S3, or
Nope.
go directly from the internet gateway?
No. An endpoint is to access that from the VPC, right?
Uh-huh.
But you can have this from the internet. Just if I give you the URL of an object, you just get the URL. I mean, get the object, right? So for these guys are they're not in a VPC. They don't need to be in a VPC. They are not.
Well, wouldn't you want to do that for security purposes? That you only access it through an endpoint in
No.
the VPC, or no?
No, it's just that they're not. When we created a DynamoDB before, we never put this in a VPC. It doesn't work inside VPC.
No, I know it doesn't, but my question is, why would you not use a VPC endpoint to connect to these two services instead of going through the internet gateway to access them? or are they about the same?
No, okay. Sometimes I'm confused with.
Don't get frustrated with me.
No. Just that I don't understand the question. These guys, they don't need to go through the VPC. They can be accessed from the internet gateway, from the internet. I give you the URL for the object, and you get it. You don't need to go through any security group or anything. Just need a bucket policy, right? A bucket policy or an IAM policy, depending on the level of security. And that's it. That's all you need. You don't have to go through the VPC. When
So
you
why not use a VPC? Okay.
when you create
Why
this,
would be the instance that you will use a VPC endpoint then?
okay. So VPC endpoints enables you to privately connect your VPC to support AWS services and VPC endpoint services powered by AWS private link without requiring the internet gateway, not device, VPN connection, or AWS direct connections. Instances of your VPC do not require public IP address to communicate with resources in the service. Traffic between VPC and the other service do not leave the Amazon network.
Yeah, I find that more secure than going through the internet for traffic unless it's required.
That is correct. You can work here and get the resources from here, right? Inside here.
Yeah.
But you may go here and get the files from here from the internet. Let's say that I think I had done this before. I don't know. Probably I did. The annoying thing, the authenticator. So if I give you this URL, you will be able to get my files. All right. If you click on that, you're gonna get my files. So I don't need to be in a VPC or anything. I just need to give you this URL because it's public, right? If it is private, there's no way you can get it, right? For Amazon DB, it's the same thing. They don't need to be in a VPC. These guys, when you create them, Amazon S3, Amazon DynamoDB, all those guys, you don't put them in a VPC when you create them. They're just out of VPC. They don't depend on the VPC. All right. So where was I here? There are two types of VPC endpoints: interface endpoints and gateway endpoints. Create the type of VPC endpoint required by the supported service. Interface endpoints powered with AWS private link. This is very private. Is an elastic network interface with a private IP address from an IP address range of your subnet that serves as an entry point for traffic destined to a supported service. Interface endpoints are powered by AWS private link, a technology that enables you to privately access services by using private IP addresses. AWS private link restricts all network traffic between your VPC and services to the Amazon network. You do not need an internet gateway, a NAT device, or virtual private gateway. The following services are supported. All of these guys, right? When you create these guys, you don't put them inside VPC.
Yeah, you connect them through endpoints. If you want to keep the connection, if you want to keep the traffic private.
I put this.
You know what I don't see on this list? S3. You see it? Nope. Oh, a gateway endpoint. That's what they're using. It's at the bottom. Amazon S3 and DynamoDB are implemented as gateway endpoints from the VPC.
It's right here.
Uh-huh.
The only services that are provided so far until now, these two services for a gateway endpoint. It's a gateway that you specify as a target for a route in your route table for traffic destined to supported service. The following AWS services supported, these two only.
So I will use something like this if I were to keep that connection, that
Yes.
link or that data flowing private.
You will use a gateway endpoint. And
that's what they're alluding in the, if you go back to the exercise, I think that's what they're alluding in the answer, right? Where this DynamoDB and Amazon S3 being inside AWS.
yes, that is correct.
It's connecting through the VPC using those gateway connections, gateway endpoints. You know, this was one of the questions in the test that I took, asking about endpoints.
And what testing for this exam?
For the cloud practitioner.
I was there. Wow.
Yep.
Do you think you got it right?
I have no idea. I read about it.
Yeah, because they don't give you the answers. They'll
No.
just tell you what areas you have to improve. That's it.
And it was one of the questions, not the same question, but it was one of the questions in digital cloud. Digital what?
Digital cloud, yes.
Yeah, digital cloud, yeah.
So
Okay.
here are some, yes, you finished, Maria?
Yeah, sorry, yeah.
No, not a problem. So here we have some videos on performance and documentation as well. So if you want these files, I can give them to you guys. Let me see here.
So good afternoon, everybody. My name is Dougal Valentine. Thank you very much.
So I'm gonna give you this. One. I'm gonna give you this. And this one as well. And this is the channel. Okay. So questions about practices. How do you select the appropriate instance types? Storage solutions, database solutions, and proximity and caching solutions for your system. The best practices are predicted resource needs. You know, the solutions are based on predicted resource needs, require internal governance standards, cost of budget, benchmarking results, load testing results, and guidance for AWS and from a member of the AWS partner network. Okay. You know, there's plenty of ways you can, you know, learn how to, you know, be within the best practices. How do you ensure that you continue to have the most appropriate instance types, storage solutions, database solutions of proximity, and caching solutions, and new services and features are launched? So this is when you start. This is when you already started. And how can you keep that and make sure that it's running effectively? So you have to review cyclically, you know, in cycles, and reselect new services and features based on predicted resource needs. For example, people were using EC2 all the time when Lambda came on. Then, you know, people started to move to serverless and now use EC2 instances. And, you know, there are many services that are launched in every event every year. This is something, guys, that you can probably attend an event. It's super good because you learn a lot, and they always launch new services in events. It's quite pricey. It's like $2,000 and something for 3 days. But if you manage to work with a company that can pay for that, that will be amazing. If you can work with an APM partner, then you can get some, you know, vouchers to visit this place, right? And attend this event. So benchmark and load test after each new service or feature is released, and use that information to make the best selection based on a calculation of performance or cost. Cost is very important. So how do you monitor your instances, storage solutions, databases, and monitoring caching solutions to ensure they are performing as expected? Well, if you just remember one of the first slides, they were talking about, you know, select, remember, review, and then monitor, right? Those are the steps that you have to take. So how do you monitor your services? Using Amazon CloudWatch and third-party tools. Also, you use Lambda, don't forget that. Perform a periodic review of your monitoring dashboards. Remember that dashboard is a universal service, a universal feature of CloudWatch. So you can have different instances in different regions, and you can see it on one single dashboard, okay? You can use alarm-based notifications to automatically alert you if metrics are out of safe bounds. Use trigger-based actions to cause automated actions to remediate or escalate issues. How do you ensure that the capacity and throughput of your instances, storage solutions, databases, and proximity and caching solutions match demand? So you have to react based on manually reviewing metrics, plan your future capacity and throughput based on metrics and or plan events, and automate against metrics. And you perform a periodic review of cache usage and demand over time. Monitor use and demand over time. Use the following for automatic management: scripting and tools, auto scaling. Okay. This is nothing new, guys. We've seen this before. So today we saw, we review compute, storage, database, network resources to improve your architecture's performance efficiency, identify design principles that can help your system achieve performance efficiency, and evaluate the most important performance metrics for your application. Our next pillar is going to be cost optimization, and that's going to be on Wednesday. So guys, if you don't have any other questions, I'm going to stop this, and then you can ask questions if you want to.